Hello everybody, welcome to Guidancee education channel. We will see the topic that is discussed in this video. We are continuing class 11 physics thermodynamics. The topic is refrigerator and heat pump. Under that, we will discuss the principle, block diagram, difference between heat engine and refrigerator, difference between refrigerator and heat pump. This topic will be of great use to you. Please watch the video completely without skipping, and if you think the video is useful, do like the video, share the video with your friends, and also leave your feedbacks as comments in the comment box below. If you're watching without subscribing my channel, do subscribe it now and also press the bell button and all buttons so that you get intimated as soon as new videos are posted. Thank you very much for your support. Come, let us start the class. We will discuss refrigerator and heat pumps as the second application of the first law of thermodynamics. The refrigerator is a cooling unit, just like the air conditioner, which we call AC. The heat pump is a heating unit. You already know we keep foodstuffs inside the refrigerator at low temperature so that the foodstuffs do not get damaged. The air conditioner cools the room or the car or any vehicle where it is fitted. In the case of heat pumps, you would have already heard that in European countries where the atmospheric temperature is very low, heat pumps are used to heat up the rooms. The working of the refrigerator and the heat pump is just the reverse of heat engines. We have already done heat engines in the previous video. If you have not watched that video, click the I button in order to watch that. Anyway, I will provide the block diagram for the heat engine here for you to refer. I will directly pass on to the block diagram of the refrigerator. You can compare the two block diagrams and understand. In the case of the refrigerator, the working substance absorbs a certain amount of heat Q2 from the cold sink, which is at a lower temperature T2. It is already mentioned that it is a cold sink. The working substance is generally a gas. Using energy from an external source, say current, work is done on the working substance when its temperature increases further. Then the working substance releases a certain amount of heat, say Q1, into the external or hot reservoir, that is environment, which is at a higher temperature T1. The working substance is contained inside the compressor. Compressor does work on the working substance using electrical energy from the power source. Compare this block diagram with the block diagram for heat engine. In the case of heat engine, heat is absorbed from a hot source. Work is done by the system, that is by the working substance, that is turning of the wheels, and a certain amount of heat is released into the cold sink. In the case of refrigerator, it is just the reverse of heat engines. Heat is absorbed from a cold source. Then work is done on the working substance, and then heat is released into the hot source. Now let us try to understand the various steps undergone by the working substance when the refrigerator works. First step, working substance suddenly expands. Pressure falls. Temperature also falls, and the working substance inside the compressor gets cooled. A vapor liquid mixture of working substance is formed. Second step, the mixture, that is the vapor liquid mixture, absorbs heat from the cold sink from this region and gets converted to vapor. The portion which has been converted to liquid now becomes vapor. Third step, work is done on the system using electric power. The vapor gets heated up. So the internal energy of the system, that is the temperature of the working system, increases further. In the fourth step, the heated vapor releases heat to the surroundings. What is the result? The temperature becomes equal to the initial temperature at the end of the first cycle. So delta U becomes 0. Now let us apply thermodynamic equation. The thermodynamic equation, delta Q is equal to delta U plus delta W. What is delta Q? It is Q2 minus Q1. Q2 minus Q1 is equal to delta Q, and delta U is equal to 0. So what happens to this equation? Delta Q, Q2 minus Q1 is equal to delta W. So for the refrigerator also, delta U is equal to 0 and delta Q is equal to the work done. Here Q2 is less than Q1. So Q2 minus Q1 becomes a negative value. So work done is negative. We know that work is done on the system. In physics, we take such work as negative. All these points, including the block diagram discussed for refrigerator, is applicable for the heat pump also. But in the case of heat pump, the cold sink is the external environment and the hot source is the room, so that the room gets heated up. Hope this video was of great use to you. We will meet in the next video with the coefficient of performance of refrigerator. If you think the video was useful, do like the video, share the video with your friends, and also leave your feedbacks as comments in the comment box below. If you have not yet subscribed my channel, do subscribe it now and also press the bell button and all button for notification of more videos like this. Thank you very much. Bye for the present. Take care.